We have another huge week this week with two really significant papers coming from OpenAI and Google. So first, I want to talk about RTX. A couple months ago, we did an episode on RT2, which was an integration of a generalized robotics model with LLMs. What they've done here is basically taken a principle that was applied in the large language model space and said, let's just take as much data that relates to this use case as possible. So for LLMs, that means just taking huge quantities of internet data, training a model on it, seeing how it performs. What Google did is they took tons and tons of video from different robotics models and different robotics applications from universities all over the world. And they created this huge data set and they trained this RTX model on this data set. And they found that the addition of this massive data set, despite multiple embodiments and so many different scenarios, created really significant improvement and generalized ability to solve new kinds of tasks. So it outperforms RT2 a ton. They actually also open sourced this data set. It's called OpenX embodiment. So more researchers can use this data set to build new robotics models, explore use cases, et cetera. So creating a massive generalized multiple embodiment, multiple camera stream type data set and training a robot on it can lead to generalized results in robotic applications. This is a huge step forward, both in terms of the performance of this individual model, but then also direction of future research, because this data set has gone public. I think that it ties in as well to a paper that came from OpenAI last week about GPT-4 V. There's a 160 plus page report describing the capabilities and limitations of GPT Vision. So I want to list a few of those capabilities. One really interesting one is visual pointing and visual referring prompting. So that's the ability for the model to follow pointers like edges, angles, measure the lengths of things, and to point to objects in the scene. Few shot learning. So few shot learning is a principle we've seen applied to large language models, wherein you give a few examples of how you want your task to be solved before asking the question. And the example they give is showing a speedometer and asking GPT-4V, what's the speed on the speedometer? Gets it wrong by applying few shot learning, giving a few examples before asking the question. They gave a few examples of how to look at an image and take out the speed on the speedometer. It was able to succeed. It's able to recognize celebrities, landmarks, food dishes. It can read emotions from images of human faces. One really cool use case is an embodied agent approach where they took a picture of the interior of a house. They're in the living room and the prompt is, I want you to go retrieve, like you're a robot and I want you to go get something out of the fridge. And the model is able to reason out a kind of search of the ground floor of the house. And basically when the model says, oh, I want to go into this next room, the researchers provided a picture of the next room as if there was a robot that it was instructing and taking pictures. I think we should mention that hallucination is very common for GPT-4V. A lot of the time it can feel really obvious. Humans are really good at solving visual problems and spatial problems and extracting information from images. Computers are not so good at that. They're really good with raw tabular data. So I'm talking about straight up missing text from images containing a lot of text or hallucinating stuff that doesn't exist. There's some major weaknesses in the model, but looking forward, OpenAI already has their next large multimodal model planned, which is going to be called Gause, and that'll be able to take video as input as well as images as input. I think with the combination of these kinds of models, we could see robotic agents in the house sooner than we think. One other capability is looking at browsers and figuring out what sorts of actions to take in a browser to complete some kind of workflow. I think it's interesting to note because just this past week, Sam Altman backed a couple of teams in an AI startup called Induced AI. And the goal of that is to automate browser native workflows. And you could see how some type of GPT-4V model would be critical in these kinds of browser workflow automations. Microsoft released AutoGen into an open beta, and AutoGen, they call it a tool for enabling next generation large language model applications. I think of it as Microsoft's version of LangChain. And the idea is not only do multi-agent chains unlock a ton of different use cases, using multi-agent chains is oftentimes necessary for putting a model into production because you need lots of checks and balances because these things hallucinate. They can act in unpredictable ways. So to make the overhead of creating these multi-agent manager checker type solutions is going to accelerate the whole process of building, experimenting, and productionizing solutions with complex dynamic workflows. AI hardware products are starting to hit the market and be announced. So I just want to talk about a couple of these products. First one is called the Rewind Pendant. It's just a tiny pendant that you wear around your neck that records everything, and it converts everything you say into text so you can go back and read that later. This would be useful in business applications for meetings. What's coming to mind for me is a bunch of really anxious people playing back awkward conversations they have throughout the day over and over instead of playing it back in their head, playing it back on their Rewind Pendant. It's a neat idea. I'm never going to buy one of these. Another product, which we don't know what it's going to do yet, but it certainly looks cool because it's backed by fashion people and designers, is an AI pin that's some kind of unexplained smartphone replacement. It's AI-powered optical recognition, laser projected display. So it's just a little pin that goes on your lapel of your very expensive Balenciaga jacket. All I can say is that the people using this so far seem to look great. They're all models and they're dressed very well. So if they're using it, I'll be using it too. Meta Smart Glasses X Ray-Ban. These look impressively not like smart glasses. Throwback to 10 years ago, Google X releases Google Glass. They look stupid. Some people say that product was ahead of its time. I just don't want a camera mounted on my head. But these new Meta smart glasses hardly look like a camera's mounted on your head. They just look like big, boxy Ray-Bans, which are trendy and hipster as well. I've seen people wearing glasses like this as a fashion statement. They do have the Meta AI assistant built in. I will not be buying a pair of these. Pixel 8 Pro is running Google's generative AI models on device. Rather than offloading this computation to the cloud, you're doing right at the edge on your phone. Last piece of news here is a model from Stability AI, which is Stable LM 3B or 3 billion parameters. Headline is bringing high performance language models to smart devices. So AI is getting smaller and smaller. Are the smartphones days numbered? I think yes. I think every product we use today has an expiration date. Maybe in 20 years, graphical OSs will be the cultural equivalent, of like a terminal interface today. And we just won't even know what it was like to have to type in your login, download an application from the internet and use our mouse to click on it. Maybe it's all going to be driven with our eyes, with our voice communication, or it's just going to be plugged directly in our brain and respond to our desires. Regardless of that, if you find any of the products that we described above funny, I recommend you check them out. And that's been all for this week. I hope you enjoyed, and stay tuned for more episodes of This Week in the Future.